Hey guys, welcome to today's video. In this video, we are going to solve one more Leetcode question, and the question is path sum, and the question number is 112, and it comes under easy. So, in this video, we are going to solve this easy question, but we have a variety of path sum, like path sum 1, path sum 2, path sum 3. So, we are going to solve all those follow up questions as well. Okay, so let's start with this one first. So let's understand this question. So here it is saying, given the root of a binary tree, and an integer target sum, return true if a tree has root to leaf path such that adding up all the values along the paths equal target sum. So what it is saying, so there will be given the root of the node, like you can see the in the method signature, you have been given as a root of the node and a target sum. So if this particular target sum is present in the tree, in the form from the root to the leaf. So if there is any path which has this targeted sum, then we can return a boolean as true, else we need to return false. So let's see this first example. In this first example, it is saying the target sum needs to be 22. So if you see 5 plus 4 plus 11 plus 2, it become 22. So that's why the return or the output of this is true. Okay, it has to be root to leaf. That's you need to take care of that. That it needs to be. It should start from the root and it should end in the leaf. Okay, let's see this second example. So in the second example also, if you see the targeted sum is 5, which cannot be achieved even though if we see this path 1 plus 2 it becomes 3 and 1 plus 3 becomes 4. So it cannot be targeted to cannot be sum up to 5. So that's why it is false. Okay, and yeah, so if we don't have anything, if the root is nothing, if it's null or the target sum is 0, so we need to return false. Since the tree is empty, there are no root to leaf paths. These are the constraint which you can see. I think this is fine. We can have up to 5000 nodes and the node value between minus 1000 to plus 1000, and the same for the target sum. So this is very easy question. So what we can do, so we will iterate through our root, and we will as we process that particular node, we are going to take that sum and keep it to ourselves, and which we can use in every path. We can compare with the targeted sum if we reach the targeted sum, and if not, we will keep on doing that till we reach to the end of the leaf. Okay, first thing is, if our root is null, then we should return false. This is our base case. Now second thing is, when we are going to say that we have found a successful solution, if I am at the leaf node, root dot left is null and root dot right is also null. Okay, since we have not surpassed this, we are at the leaf. So that's why what we are going to check, we are going to check our target sum is equal to root dot val. So if you would have passed this leaf node, then we would have checked target sum equal to 0. But since we are at this and we have not yet subtracted from the target sum, then it must be equal to root dot value to make this as true. Okay, else what we are going to recursively call return this path sum root dot left, and we are going to subtract this target sum from root dot value. Okay, or for root dot right, if any of the path returns me true, then it's a true for me. Okay, we can simply write target sum minus root dot val. Okay, so this is our clean and simple solution. So one thing, if you are having difficulty in understanding this, you can think of, if any of our later path returns true, then we return true, else by default we are going to return false. Okay, since we are subtracting the target sum, or else what you can take help, you can take help of a helper method, and you can add as a current sum, and you can keep on adding also. So this is much easier because we don't have to take any extra variables, so that's why we are using this particular way. Okay, let's try to run this. So it ran properly. Let's try to submit this. So yeah, it got submitted. Okay, hope you understood this. See you in the next. Thank you.